Hey guys, this is Donald Eslick with Zynex Medical. Today we're going to be talking about the NexWave and IFC, interferential current. So, we're taught during training, when we go into the clinic, we're carrying our NexWave and somebody says, well, how does the NexWave work? Well, it releases a natural endorphin. Or you say the gate control theory, and then somebody says, what is the gate control theory? And you're like, it's a gate. It's controlled theoretically. So if somebody asks us, hey, what is the gate control theory and how does this NexWave actually play a role in that? So this is kind of what you can say. Here's some good education on it. So in the 1950s, an Austrian neuroscientist named Dr. Hans Nemec, he basically developed interferential current therapy, IFC therapy. It wasn't really used for about 15 years or so until 1965 when Canadian psychologist Robert Melzack and British scientist Patrick D. Wall started using interferential current to treat pain, and they tried to really dig into why. And so those two gentlemen developed what's called the gate control theory. So IFC, interferential current, works by having two medium frequency currents, 4,000 hertz and 4,100 hertz. You can see that on the little data sheet on our NexWave brochures. And when those two currents cross each other, they then create, they basically kind of not cancel each other out, but basically what happens is at 4,000 hertz, 4,100 hertz, you now have an output of 100 hertz, so a lower frequency. In 1965, Melzack and Wall proposed the large diameter, low threshold nerve fibers are affected best by 100 hertz. And that uses the pain gating system to provide analgesic effects or pain relief. So let's dig into this gate control theory. So I'm kind of an anatomy and physiology nerd, although I don't know a ton, but I do like researching it and learning more. So say I am visiting corporate this fall, I'm in Colorado, and Steve Fox says, hey, we're in Colorado, let's go for a hike. Steve and I are going out for a hike, and I step on a rock the wrong way and twist my ankle. So at that very moment, I now have excruciating pain going from that ankle to my brain. And so how it works is at that site of injury or pain, you have C fibers and A delta fibers traveling along the nerves to the dorsal horn, which is a part of the spinal cord. And then from there, it goes north, so to speak, to the brain to let the brain know, hey, this guy's injured, he's hurt, we need to stop him in his tracks. And in that moment, at the exact point of an injury, pain is a very beautiful thing because it's designed to do what it does. If I didn't feel pain, I would continue walking and therefore cause more injury to that ankle. So now that we're back at corporate, Steve and a few other folks grab a NexWave and using the 4 electrodes, they box in the pain, as we say. And so now this is the gate control theory that Melzack and Wall really talked about. That if we can send another signal, this is not the best term, but parallel, so to speak, to those C fibers and A delta fibers that are sending pain to the brain, if we can send a different current alongside those fibers, and as they hit that dorsal horn, the stimulation from the electricity of the NexWave or of interferential current, as it enters the dorsal horn, it creates collaterals releasing a chemical called GABA. What do we think of when we hear GABA? Gabapentin. So GABA is gamma alpha butyric acid. Nobody needs to know that. And that chemical, GABA, blocks or at least slows down those C fibers and A delta fibers from going to the brain. So now we're telling the brain, hey, this guy's not in nearly as much pain as we thought he was. And that's where we want to be. Because we can now reduce pain from a 10 out of 10 to a 6 out of 10 or a 3 out of 10. Or we can bring a patient that's always a 6 out of 10 year round to now a 2 out of 10, and he's barely uncomfortable. And that's pretty cool. And that is the gate control theory. As always, if you have any questions, please contact your ASM, or you can reach out to me with the information on the bottom of the screen.